So hello everyone and welcome back to another video on NS-3. I'll just play this animation without wasting much time. So if you can observe on the screen, these nodes are moving in such a way that the human actually or we specifically how people actually move. So in today's video we are going to deep dive into something that takes your network simulation to the next level. Basically we'll be talking about human mobility model. Especially we'll explore the SLAW mobility model, which has the realistic approach to simulate how people actually move. So this I have simulated using SLAW mobility model. And today's video we are making because we had a comment on recent video by Saubhagya, where we had talked about OSPF in networking. So where we had explored about OSPF packet formats. On that video this guy is commenting about requesting like how can you please make a video on self-similar least action walk mobility model. So this is a video for you Saubhagya and everyone who is curious about this SLAW model or in general any mobility model inside the NS-3. So without wasting much time, let's get started with today's video. So just for the records, this is not something that we haven't covered till now. So we haven't covered the SLAW model specifically, the SLAW mobility model specifically. But if you just search for the NS-3 and go for the channel, and if you can search inside the playlist for this NetNM with NS-3 playlist, and if you view the full playlist, so here is the full playlist on NetNM where we had explored the mobility model or mobility helper, where we also had explored about the constant acceleration mobility model and the random movement mobility model, and there are some things that we have similar things that we have explored. So this is in today's video we are going to talk about SLAW mobility model. So that's another type of mobility model. We had already covered constant and random, as I have told you. So let's get started with this video. So I assume I'll not talk about the what you can say what is NS-3 and what is NNM. I'll assume that you all are aware about this, and if you are not aware about NS-3 and NNM, I suggest you to watch the some of the videos from my existing ones, so you will have a better idea on it. Now coming to the Saubhagya's doubt. So we have this SLAW model which is not directly included inside the NS-3. So we are required to install some prerequisite or some tools on top of NS-3 to actually provide us the ability to simulate our network topologies with the SLAW mobility model. So if I'll tell you about SLAW first, I'll just search over here SLAW mobility model. Yeah. So as you can see in the Google search, SLAW stands for self-similar least action walk. It's a human mobility model that mimics how we move in real life, unlike the random movements or the constant movement that we have seen earlier. So the SLAW builds on 5 key behaviors seen in the real human data. So those 5 behaviors are the first is we pause more at certain places. We mostly travel short distances. We have favorite spots which we call it inside this SLAW as a cluster. Then the distance between encounters follow a power law. So we reduce the power that we consume for walk. And we are lazy. So we take least action path for most of the time. So that these are the 5 behaviors on which the SLAW model is built on. So NS-3, as I said earlier, NS-3 doesn't have the inbuilt support for the SLAW. So what we can do is we can use this tool called BoonMotion. There is another tool called SLAW++, which is a C++ command line tool. But I haven't explored that tool, and this tool, the installation of this tool BoonMotion is really just as easy. So I'll be using this in for the today's demonstration purposes. So first we need to make sure that we have the Java installed. So I'll clear the screen first. Over here also I'll close this NetAnim first. I clear this screen. Now for us to make sure that we have Java installed, we can go ahead and check go ahead and run this command java-v. Okay, so java-v. Okay, java-version. Yep. So this is the command for us to know if we have Java installed or not. If we have the Java installed, then this command will tell you what is the JDK version that we have installed in our system. If you don't have Java already installed in your machine, what you can do is you can just give this command sudo apt install default gre. Sorry, not gre, default JDK. Okay, so as you can see in the screen, default JDK is already installed and it is already the newest version in my machine. But running this command in your machine will install the Java, and the environment variable will be set by default if you run this command. Now what we need to do is we need to download the latest version of BoonMotion. So we can just click on this link. So I have already downloaded this one. So if you click on that link, you will be the download will be started for the zip file of BoonMotion. Now we can take this BoonMotion inside the workspace folder that we have created for, let's say, our NS-3, or you can just unzip it wherever you want basically. So I have this file copied over here, and I have extracted this file using the unzip command. So you can directly double click and extract here on itself only using the GUI if you have Ubuntu, but for the command you can use unzip command. Now if you go inside this folder, so there will be this install file. So what you can do is I'll just go inside that folder, cd./BoonMotion. Now if you see, this install file is already there. So you can just execute this install file using /install command, and if you do that, the BoonMotion will trigger all the files, configure all the things by itself only. And after that process is done, what you can do is you can go inside the bin folder where you will have this thing called bm. Now this bm is a command by using which you can generate the trace file for the SLAW, SLAW. And there are it is not just for SLAW, there are so many mobility models, and to list all of that we can use the command bm inside this bin folder. Or instead what we can do is we can make a soft link using this ln-s command. So to make a soft link, what I have did is, if you just use the echo $path command, which will list all of your environment variable paths. So here is the path for me, user bin. So inside the user bin folder, I have created this link, soft link for the bm, which is pointing to the actual file of bm, which is inside the workspace, BoonMotion and bin folder. You can still run it from the bin folder, but if you want that bm command should be available from wherever you want to execute, so you don't necessarily need to be inside this directory. So you can make a soft link over here, and it will be accessible from anywhere from your terminal after you make this link. I have created the similar thing for the NetAnim also. I haven't created anything for the NS-3, but you can do the similar thing for NS-3 also. So in this tutorial, if I am using NetAnim command from anywhere or bm command from anywhere, you can have a context that I have a soft link created. So from the bin, coming to the point like from inside the bin folder, we can execute bm command, which will list you the help page of BoonMotion page, the BoonMotion command, actually the application. So to list all the modules, you can use -hm command, -sm option, which will print available modules. So we can just use bn-hm. So you see, it will list all the available modules. So there are so many modules: bound list, Gauss Markov, then purse, random direction, then there are so many different other, but we are focusing on SLAW. Now SLAW, which is application to construct mobility scenario according to the self-similar least action walk model. So now what we are required to do is, we can give this command bn-hm SLAW, which will list all the configuration options, all the available configuration options for the SLAW model. So you can see the current version is 1, description is this, then who are the authors, contact, and references. So for us to actually configure this thing, see the trace file, which we can use it inside the NS-3, what we can do is, we can use the command called bm-f, and we can give the file name, let's say file, any file name which you want for your trace file. Then we can have -hm, sorry, not -hm, we can give the mobility model that we want to use while we are generating the trace file. So we can use SLAW, which is the main focus for today's video. Then we can have the configuration for these options. So I will not use every one of these options, but there are certain recommended options, such as -n, which is how many nodes for which we want the trace source file. So let's say we want trace source file for the 20 nodes. Then we can specify the width of the simulation area by -x option, let's say 1000. Then we can specify the height by -y option, let's say 1000. Then we can provide random seed, which means the random order for the nodes to render, so let's say 50. Then we can specify the SLAW parameters, such as -w, which is number of waypoints to generate. Let's say we want to generate 10 number of waypoints. So waypoints means the nothing but the common, let's say, points where the humans are most likely want to go. Then there are certain other options for us to use, and that you can use according to your need, but this is the basic configuration for us to do. Now we can give this command. Okay, so what happened was, so the random seed is too large, so that's why we had an error, something called variance too large, try again. But if you keep the random seed really low, I mean not really low, somewhat low, then the trace file will be generated successfully. Now if you hit the ls command, you will have this file name .params file name -waypoints.csv, but these are not the files that you want. You want the trace source file, which will have the extension .ns-movements. So to generate that file, we are going to use another command, which is bm ns file and followed by -f and followed by the file name, which will generate the file name .ns-params and file name .ns-movements. So this is the file that we want, and what we are going to do next is, we can copy this file. So we can copy this file .ns-movements, and if I'll show you, so in the workspace folder itself, we are currently inside the bin folder, and in the workspace only I have this ns all-in-one, I have this bake folder under source I have this NS-3.37, and under this SRC we have something called mobility, and inside mobility we have something called helper. So we want this file to be here, so we can copy that file using GUI, but we can also do it using command. So we can go one folder, two folder actually, up the directory structure. Then we can go inside bake. From bake we can go source. From source we can go NS3.44. From NS3 we can go SRC, source directory for the NS3. Then we can go for the mobility module. Inside mobility module we can put this file, we can copy this file inside the helper directory. Now this file is copied over here, as you can see. Now if we want to use this file for the NS3, so what we can do is so this is the sample file which will do nothing, this file is just there to simulate the what you can say, the node movements. But you might have some topology where you want to simulate this kind of node movement, where you want to simulate this kind of node movement that you have configured using the BoonMotion tool. So what you can do is you can just use this code to apply that trace sources, I mean the movement pattern, by just replacing this location, this file. So what we can do is we can copy this file name. Actually I'll use the rename. I can copy this file, I can just copy this file name. I can just go inside the Visual Studio Code and I can just paste it over here. So this file is currently has this many modules. Now let's say we have some node containers. Now we have this mobility helper. So this mobility helper will help to generate this animation, help to generate the movement pattern for the nodes. And in between these two we might have the code to generate the topology, and this will simulate for 600 seconds. So now we can just run